Please come on in, take a seat. Lots of room still over here in the back. Some seats up here at the front as well. Don't be shy. Don't be shy. There you go. Take a seat. I'm talking to you, Chris. All right, welcome back, everybody. I hope you had a nice break. Feeling refreshed, hydrated? Yeah, good? All right. Our next speaker needs almost no introduction, but I'm going to give her one anyway. Her name is Sasha, and she's actually coming home for the first time in 15 years. Everybody, please, a big round of applause for Sasha.
Всім привіт. Я з України, але я живу в Штатах уже давно. Hi, I'm Sasha Rosenbaum. I work for Microsoft Engineering, and this is a talk about Microsoft DevOps journey so far. Right? And the reason this is a great talk is because we're still in this transformation, right? And we started, a few years ago. And when you think about Microsoft, you're like, okay, this is a big company with lots of resources, and they can do all these things that we cannot do. But if you really dig deep, we're a 44-year-old company, right? And we have tons and tons of legacy software. And we have all this organizational structures and culture issues and stuff that we had to sort of evolve and adapt out of, right? And we're still in this process because it never ends, and so we are continuing the improvement. And I'm going to share with you some of the things that we learned along the way. So first thing first, the introduction. So I don't have a big picture of myself on my first slide. Probably will have the next time. So anyway, I am an organizer for DevOps Day Chicago. So that's an awesome conference. It's happening on August 28, 29 this year. If you need an excuse to be in the States, this is a great time to be there. So I published a book on serverless computing in Azure with .NET about 2 years ago. It's like 99% outdated right now. So the chapter on architecture stayed relevant for a little bit longer, but now I fear that even that is getting outdated. So do not publish a technical book. It's not going to last very long. And in my spare time, I do like to hike mountains. It's not quite climbing, but I do like to hike to very high places. So, okay, I do work in Microsoft Engineering on a product called Azure DevOps because we're great at naming things. Despite what the name says, you cannot buy DevOps from us because DevOps is not just about tools, but we do have all of the things that go into your product lifecycle as part of this product, right? So let's start with trying to define DevOps a little bit. There's a lot of definitions out there, but this one, in particular, we really like, and that says, I'm going to read from the slide, DevOps is the union of people, process, and products to enable continuous delivery of value to your end users. Now, thank you for that. Sound effects. So, what I like about this thing is that you notice it doesn't even say delivery of software, right? It says delivery of value. Because in the end of the day, what we care about is that we put something valuable in the hands of our customers, in the hands of our users, right? Because if we don't do that, then why are we actually doing our jobs, right? We're not just out there playing with software, even though sometimes we are, but we usually do have a goal. And so this is all where this all originated. So the people who coined the word DevOps, they were talking about breaking the silos between developers and operations, because people used to be incentivized for radically different things, right? We would tell developers, okay, you need to build cool stuff as quickly as possible. Okay? And then we would tell operations, okay, you need to keep the lights on and make sure that the site never goes down. And so this would create different incentive for them, almost put them against each other, because one part would be, okay, we want to change as soon as possible, and the other part would be I want to sleep at night, stop changing my stuff. Right? So DevOps actually came to sort of try to remediate this. But it did evolve from just, breaking the silos into all sorts of different things that we now talk about, including continuous integration, delivery, and all these things. So why do we even do DevOps? Why is everyone so hot on this topic? And it's been around for 10 years now, right? So we're about to celebrate a 10-year anniversary, and it's still so popular. So these numbers actually come from, and there's a lot of words on my slide, sorry, they were not built by me. So these numbers come from something called the DORA report. So they go around primarily in the United States, and they collect all these metrics about companies that are implementing DevOps versus not implementing DevOps, right? And what they find is, if you notice on this slide, is like people who are further along with their DevOps transformation, they're like spend a lot more time building new stuff, right, on innovation. That is a 50% there on innovation, and a lot less time just keeping the lights on, doing the maintenance, and a lot less time remediating, right? So stuff breaks less often for them. And it's like they go faster to production, but they also break stuff less often. So that is like a unicorn, right? There's a lot of things out there, like Kubernetes is going to solve all your problems, and your virtual private cloud is going to solve all your problems. I mean, but I believe that DevOps is actually that one unicorn that is going to solve all your problems. At least if you approach DevOps is that approach to continuous improvement. Okay, so let's talk about the journey. So this is a journey for one particular team inside Microsoft, but it's kind of representative of a lot of teams inside Microsoft. And this is a journey that we started from TFS. I don't know if you guys, who is familiar with TFS, Team Foundation Server? Okay, some people have experienced that pain. That's great. So basically, we started from a box product that we delivered. So this is not even on the slide, but in 2005, we introduced TFS 2005, and we delivered it in 2006, which tells you a little bit of the story, how great it was, right? And so then we progressively got from this box product that you had to install on your machine and work it yourself to a SaaS service, and then to making continuous improvements to the SaaS service. And so this is some swag numbers. It's like, oh, cool. So Azure DevOps is a tool chain that right now is used. So this is only internal for Microsoft, not for external customers. So it is used by 100,000 engineers inside Microsoft. It's like we're privileged because we have these numbers, right? We can have internal users at these numbers. And we're doing, so this is from March, so a couple months ago, 82,000 deployments a day. That doesn't mean 82,000 deployments in production, but it's 82,000 deployments somewhere, right? Some product in some environment is deployed using Azure pipelines. And some other like cool numbers on here. So we went from completely closed source company, right? We have now 3,500 open source projects out there that Microsoft engineers are contributing to. And it contains both our internal products, so like docs.microsoft.com, our documentation is open source, is on GitHub. If you find problems with the documentation, if something's outdated, you can go in and submit a pull request, and we'll actually merge it into our documentation. So like we empower you to like contribute to our stuff. And the power of pull request here too is that we can actually review the stuff you've written. And that is also true for some of our internal products, right? So Azure Functions, for instance, is completely open source. So if you like, working with Azure Functions one day, and you're like, it doesn't scale as good as I want it to. So like, you can go and contribute code to our, actual stuff, and we will run it through our testing and potentially accept your changes. Maybe then hire you too. But okay. And then yes, we do also contribute to like other people's projects, right? So it's not just internal Microsoft stuff. We contribute, for instance, to upstream Kubernetes and the tools like Helm and Chart, Draft and whatever. So we actually write code that goes into everyone's Kubernetes. So if you're running it on-prem, and if you're running it in AWS or anywhere else, it actually still has code written by some Microsoft engineers. So this is a huge mindset change, right? From being like very, very closed and very, very like, you should only use our tools, to like being completely open and contributing to open source. Okay, so let's talk about the journey. So this is a long conversation, so we'll see how much of that we can actually go through in the 40 minutes that I have. So the first thing first, and we became customer obsessed, right? So we used to sort of decide on the product that we're going to build, right? And we went into a bunker, right? And we thought about what the customers maybe wanted, and then we built it for 2 years, and then we gave it to you, right? And then like you had to deal with whatever we gave to you, right? Now we actually, we take feedback from everybody all of the time. So for instance, we have developer communities. So if you submit some feedback on developer communities, it actually goes into our boards and becomes our work items. So that's pretty cool. We monitor Stack Overflow. We actually have like PMs going and answering questions and looking at issues. If a lot of people are experiencing an issue, we're going to look into it. We do have this little thing in the product itself. You can submit feedback on the product. So you actually can make a suggestion. So if you're like, okay, this would be so much better if this button wasn't here, but it was here, like you can actually go and tell us that. And we actually like that because it tells us what real users of our product are experiencing in production. We do have this NPS score feedback dialogue that pops up and annoys you sometimes. And so this is a funny story. We noticed a reverse correlation. So there's a lot of people working on like day-to-day, like Monday through Friday stuff with Azure DevOps pipelines, like or whatever. And there's very little users, working during weekends. But actually, the users working during weekends are for some reason a lot happier with the product. So I don't know why that is. Maybe that's because they're building their personal products, because we do have an awesome free tier. I don't know, but this is kind of cool. And like one more way we do solicit feedback is we assign every engineer with a couple of customers. They're typically the largest customers, but we do sort of assign planted customer representative, right? So engineers are not siloed from the customers and just building the product, in their own room and never talking to a customer. They are actually assigned to be an advocate for someone externally that is working with a product. So that's another way that we solicit feedback. So, okay, this is an interesting one. So our definition of done. So this started with TFS, what was it, 13, 14 years ago, right? So back then, there was such a thing that was called code complete, okay? And code complete meant that every team that was delivering feature decided that they have implemented all the code for the feature. It didn't mean that the code actually worked, right? It meant that we finished writing the code, okay? And I wasn't at Microsoft back then, right? But the legend says that from the time of code complete to the time that we actually were production ready, it took 6 months of merging and remediation and trying to figure it out. Yeah, that's how great it was. So that obviously was a problem. The legend also says that 99% of our builds back then were not only not production ready, but like I said, it was a box product, you had to install it yourself. So 99% of our builds would actually bomb your machine so bad that you had to not only reinstall the product, but you actually had to start over with Windows because it would be completely dead to that extent, right? So you couldn't actually go and install TFS yourself. You had to hire a consultant and pay them a lot of money to just be able to use their software. That's awesome, right? So then from that, we actually went to, when we decided to do Agile, we went to potentially shippable. So potentially shippable is a lot better than code complete, right? Because that means it actually compiles and it runs and it potentially works for you, right? But there's still a lot of things that could go wrong with that definition. So then when we started doing the lifecycle, like the SaaS product, which was called VSTS at that point, we started doing live in production and used by customers. So that was our definition of done. Again, major transformation. This is awesome. Now for me to say that I'm done writing my code, right? It's not just after we've completed the sprint and whatever, but for me to say that I'm done writing my code, it had to be used by at least a couple customers in production, right? So that's a great definition of done. The only problem with that was that we still so we didn't actually know if customers like it, right? We didn't know if customers really use the feature, and we didn't know if customers actually like the feature. So then the current definition of done that we have, and it's probably the best one so far, it's live in production and collecting telemetry, supporting or diminishing the starting hypothesis. So Paul talked a little bit about this, but what we do right now is not we decided to implement this feature, right? But we actually start with an assumption. We say our stories are phrased in a way of maybe we think that if we implement X, our customers are going to enjoy this. right? And then we deploy it to production, and we let our customers use it. We also let our customers to opt in into using it, and we're going to talk about it some more. And then we prove or disprove that hypothesis, right? Because if we see a lot of customers opt out, we actually turn it off. Right? So that's like much, much better than other definitions of done that we had. Now, okay, this is a good one. So we measure a lot of things, right? So we measure, for instance, we measure acquisition, engagement, satisfaction, and churn. So that is, again, is this used by customers, and are customers happy with the thing that they're using, right? Then we measure velocity in terms of the tool. So CI/CD, right? How long does it take us to build? How long does it take us to test? How long does it take it to deploy to production? So these things are measured. We also measure lifesite health. So how long does it take it to detect an issue? How long does it take it to remediate and such things? Customer impact. We also do something that's customer-specific SLA. So like we have over 1 million customers on this product right now, and it's really easy for us to say, okay, it's working for 99.95% of people, right? It would be really easy to say, okay, we're live and working almost everywhere. But then every now and again, you have this customer, and maybe they're using a different setup, and it's just not working for them. This stuff is consistently breaking. So we look into these outliers, and we actually go try to remediate it, find out what's different about that setup, and try to fix it, right? So things we don't measure, that's important. We don't measure lines of code, right? I hope you don't either. We don't measure the number of bugs that you found because that, tends to find a lot of bugs that are not really bugs or whatever, but the numbers get pretty high. We don't measure team capacity, burn down, or velocity. So engineers tend to be smart, right? And like Paul, and if you give them a metric, they tend to start gaming the metric, right? So if you start measuring something like team velocity, what happens is the team then starts estimating the stories just a little bit differently, so their velocity looks a little bit better than the team B, right? So this is awesome. We're delivering so much more value, right? Because their numbers are so much greater. So instead of measuring things that could be easily gamed, we measure for things that are actually value to customers. So if you want to game customer satisfaction, be my guest, because that actually probably means that people are happy with the product, right? So if you can do this, great. Okay. So this is on the customer obsessed. And okay, so this, to me, this is like the most important part of DevOps, and this iterating over pain, right? So how do you actually get from where you are to where you're going? And this is a really complicated question, because when you start this journey, you're like, oh my God, I got 20 years of legacy code, and nothing is best practice, and we can never get to Kubernetes, and I don't know, we don't even know these programming languages, and I don't even understand what you're talking about. And I don't know, everything is manual, everything sucks. So the thing is, if you start small and you start remediating where it hurts the most, that's a winning thing. And so you find that one thing that consistently you get support calls every week deploying the software, and that is one thing that's breaking every time, right? Go and fix that. Your life is going to magically become a lot better when you do that. And not only that, but a lot of times you discover that you only need to fix it a little bit, right? And then the next pain is elsewhere. So that's another thing that, a lot of people are like, okay, so let's say TFS. TFS was a huge, huge monolith, right? Everything was in the same code base, and everything was compiled together. And we could have said, okay, we're going to break it all out into all these microservices. But that would realistically be, again, another 2 years of work that would take us, down and make life horrible for us. Instead, what we said is, okay, so whenever we see a service that really makes sense logically to break out, we're going to break that one out. That one that makes sense, that needs to scale independently, be deployed independently, or whatever it is, we're going to break that one out into microservice. Right? So you kind of iterate over these most painful things, and you will discover that your life gets better over time. So one of the things we insist on in terms of that continuous improvement is, so one of our biggest pain was the merge hell, right? So that 6 months of integration. So what we did is we decided, so first of all, we did switch to Git completely because it makes more sense in terms of workflow. But we did switch to trunk-based development right? And we have these short-lived topic branches, and we do have a release branch because it takes us like 3 weeks to deploy to everywhere in production, and we can talk about that some more. But in general, so like we do all commit to master all of the time, and all the code is shipped from master, right? So we don't like go into a branch and live there for a long time and like then have the merge hell. So that helps a lot, but how do you use that and still, like, if you have a feature that takes you 3 months to implement, like, how do you actually deploy from master, right? That's the next problem. So we do use feature flags. As some people say, it's a fancy name for if statements. But it is a little bit more complicated than that, because like if you're doing feature flags, what you need to do is to make sure that your code works with both configurations, and potentially you can have multiple of these feature flags. So you kind of need to maintain the data in a consistent state across all of these different configurations. But what it enables you to do is enables you to launch things darkly without your customers actually seeing that. So every feature in Azure Pipelines that is there, it's probably been there for 6 months, you just didn't know it. Right? And this enables us to test, and it enables us to release it to some subset of customers and let them play with it before we actually go live with everybody. If you do go to the tool, you will see that in terms of the UX, a lot of these are opt-in and opt-out, so you can actually turn something on and turn something off, right? There's a lot more of these in the back end that we just manage ourselves. But in terms of the opt-in, opt-out in the UI, right? If we see, so our threshold is 95% of people. So 95% of people have to opt in for us to keep that. And if it's the percentage is less, we're not going to release that feature to everybody. And the reason is that UI is like a joke, right? If you have to explain it, it didn't work. Okay, that bombed. I had to explain it. That's fine. Okay, so we do have production first mindset. So this is another thing. People think like Microsoft has all of these resources and all this money and all these smart engineers, and you guys can do things that we can't and whatever. But the thing is, like, we didn't, up until just a few years ago, we had no SaaS products. We never ran services, right? We knew nothing about running Lifesite. All we knew about is shipping a box product of this kind or another, right? And we never had to care about anybody's production. So from there, we had to build all these muscles, acquire all these skills of like SRE and how do you deploy to production and how do you support production, and how do you deal with customers live on your site, submitting telemetry and all that stuff. So this is something that and I could talk more about this, and we don't have a lot of time, but like, for instance, we assign all the engineers to support calls. So like every single person in engineering does this like support duty for a day in like a month, I think, where they get customer support calls. And that builds empathy, because like you can't just be like, oh, these users are too stupid, they just don't understand my software. Like, no, you're getting the calls and you're like, okay, this doesn't work, like explain this to me, right? And this is a great thing to do. Okay, there's no such thing as partial automation. So in terms of automation, a lot of times what happens is like, it will take you 2 weeks to build automation for something, right? And you're like, oh, I can just type this PowerShell command in 10 seconds and it's just gonna work, right? And so we had a lot of this. Like we had a lot of people having like OneNote and Notepad++ or whatever, and they had like these partial scripts and these like checklists and whatever. And so what happens is that you break production, right? Because like, I don't know if you noticed, but like, if you paste, a PowerShell command into OneNote, like you usually get smart quotes, and then it breaks stuff in production. And that particular one didn't break all of production, broke some one environment somewhere, and took 2 weeks to find. So this is great. So we actually said like, there's no such thing as partial automation, right? Everything has to go through pipelines or automated scripts. Everything has to be in source control, right? And like, no matter how long it took us to actually implement that automation, we actually made a point of doing that, because humans are just like not good at doing repetitive tasks, right? Complicated repetitive sequences. We're not good at that. That's why CI/CD works, and you should all do it. Okay. So yeah, we're doing automation. That's good. And then another thing that in terms of like deploying to production that we're doing is, so we assume that we're not gonna, rock every change 100%, right? So we won't be able to continuously deliver non-buggy code forever, right? So what we do is like ring-based deployment, and different services like in Azure do different rings and different names for this. But in general, the process is we deploy first to internal users. So anybody who's at Microsoft. So I have an internal organization in Azure DevOps, and I have like an internal Azure subscription. I get the updates first. And the idea of that is in the few hours that we wait before we deploy to the next ring, I am going to call the team next to me and be like, hey, you broke something, right? And then we deploy to this like one small region where we have customers that are like opt-in, volunteered to like test their stuff, and then we deploy to the next region in the U.S. and then like gradually it rolls out to all of the world. So this is kind of like limiting the blast radius of every single change. Okay. So this is great too. It's about teams. So this is like in terms of reforming organizational culture and all of these things. And you can actually do that. It does need to come from up and down somehow simultaneously, right? And then the middle management is the one that screws it all up. It's fine. But so this was in 2011. Someone at Google drew an org chart for all the big companies, and then a lot of people found it accurate. So this is the Microsoft org chart. And this never happened. I mean, like we never had like separate products that were all competing for the spotlight and Anyway, so we had to like remediate against that and find a way to like do this better. So like someone read this awesome book, it's called Drive by Daniel Pink, and it talks about how like research says that the 3 most important things about your job satisfaction are autonomy, mastery, and purpose, right? So if you give people that, they're probably going to be happy with their jobs, right? You probably it is about money, but once you get enough money, it's probably not the most motivating factor, and it's not about like getting bling, although that sometimes tends to be important. But so we did that, and we said, okay, how do we give engineers that autonomy, mastery, and purpose opportunity? So one of the things that we did is like we said teams have complete autonomy about 2 things: plan and practices, right? So you can choose your own process. If you're in Microsoft engineering, you can choose your own process of delivering software and of work planning. So as a for instance, if you wanted to do Waterfall at Microsoft today, and your team will all agree that Waterfall was the greatest thing since the bread came sliced, like you could actually do that. I don't know anybody who's doing that, but you could. Now, Paul talked about Kanban versus Scrum and all of these things, so I actually only know a couple of teams inside Microsoft that use Scrum. Our teams are largely on Kanban, and nobody mandated that. They just kind of generally converged towards the Kanban because it made more sense. Because we are delivering features continuously into production, so it doesn't make that much sense like, okay, I need to measure my team velocity and plan for the next 6 months and estimate delivery. No. Actually, 80%, I don't know, I'm just throwing numbers out there, but probably about 80% of our work comes from customer feedback. Right? So we didn't actually, the PM doesn't actually say, okay, this feature is the greatest thing. No, we actually get all that feedback that we talked about, and then it actually gets absorbed into our work items, and that is the next thing we're probably going to work on. The things we do align on is organization, the roles, and cadence. So cadence was a big one because we discovered that if you let people manage their own schedules, they don't have a common language, so they don't understand. They're like, okay, when is that feature going to be delivered? Well, it's in this sprint, in sprint 55. What does sprint 55 mean? We don't know. We are on sprint 42, right? So that was really hard. So that was one of the things that we did. So in terms of team structure, so we used to have program management, development, and testing. And so testers were actually software engineers with the same education and experience, but they were assigned as testers. So they would be writing tests, and then there would be engineers writing software. And we discovered that it didn't work that well, right? Because once you give those teams different names, you kind of create, again, different incentives for people to care about different stuff. So we actually merged the teams. And so now all the titles at Microsoft, you're either PM or engineer. There's only 2 titles. And the ops team over here, they're also all engineers. So you can only be one of the 2 roles in Microsoft engineering. And then the other thing that we did was we aligned those teams around features. So instead of aligning them around like process, right? So like your ops and your like UX and your like engineering, whatever, you are aligned about something, that piece of value that you're delivering to a customer. And your team has to have all the skill sets that are needed to deliver that piece of value to a customer. And you're also actually responsible, right? So it's not somebody else who gets these calls, right? You are getting the work items and you have to fix it if it doesn't work. So that was like a great thing that we did. And then another thing is like, we didn't do horizontal. I don't know if we ever did horizontal, but like it definitely is all vertical. So like all from the ground up, that, you know, team is building the entire thing. And we do have like, we sort of like have 2 pizza teams that are co-located. So we do have locations around the world, but the team that builds a feature, generally we try to locate them in the same country and probably even in the same office so they can actually talk to each other. And we do have this, like, this is a nice thing. About every like 12 to 18 months, there's this thing where they go like, okay, people can switch teams. Right? So they can switch teams, they can choose to work on another project. So they don't have to go through rounds of interviews and go like, you know, talk to managers and whatever. What actually happens is that team leads come in and they pitch the projects they're working on. They're like, my project is the coolest thing. I'm building Python support for VS Code or whatever. Like, it's amazing, right? And then the engineers can choose where they're going. And so like everybody can switch teams. We find that it's about like less than 20% people that actually switch because they usually do like what they're working on. But you do have that opportunity to, without jumping through a lot of hoops, just go to the next thing. And yes, you can actually, you know, like integrate different cultures from different teams and work on new things that you wanted to hone your skills on. And then I did mention this a little bit, but we do have like the sprints alignment across pretty much all of Microsoft. I don't know if it's 130,000 people company, something, but like every team that I know of is aligned on the same sprint structure. So we also like deliver on the same cadence, so we can get aligned on different things. And we do have like OKRs. OKRs is highly popular right now. So objective key results that we measure. So we do like check them every 2 sprints, and then we potentially revise them every 4 sprints. So that it's not like again 2-year planning that we're talking about. Okay. How am I doing on time? Okay. I'm still, okay, so shift left, quality. All right, so engineers are really great at naming things. There's like only 2 hard things in computer science, but so we argued a lot about like what is integration tests and what is unit tests and what is like system tests and whatever. So in the end, eventually we just decided to name them with numbers. Right? So like it's easier. It's like L0 through L3. And so L0 are the tests that are like complete mockups, right? They don't have any dependencies. L1s have dependencies on SQL and potentially the file system. And then you go into like test service, like integration tests. And then you go into like full environment. So like you deployed something and then you do like, you know, UI testing and stuff. So where we started this, I think is 2015. The current test portfolio picture, right? So it was all L3s. There was like lots and lots of UI tests and lots of integration tests because we thought that was, you know, the best thing that could test our software. But the thing is, like, UI tests are not always that amazing. So like one of the examples that people like to give is the one from Etsy. So Etsy did this, like they had no manual testers, and they did, on their website, they did a lot of like automated UI tests. And so they publish a change to the site, and their sign up, like new user registration goes down, like completely down, right? And so like 2 days pass, and they're like, what did we do? Did we screw up marketing? Did we do this? Did we do that? Finally, someone decides to go actually, you know, shockingly go look at the website, right? And they discover that there's no registration button. Like, where the hell did the registration button go? Well, someone published a change to CSS that made the color of the register button the same as the color of the background. And their perfect Selenium test was like, yep, I can click register, and that works just fine, right? So, you know, your UI tests are limited, and so like what you ideally want is to have humans actually looking at it. And we are lucky in that sense because we have, like I said, we are our own testers, so we use our own software. So a lot of the bugs are found by us, right? But we do believe that like where we're going is like very little UI tests and a lot of integration tests. And the reason that we can do this is because, so we used to have nightly builds for like VSTS, and they were not nightly, they ran almost 24 hours because of the tests, right? And not only did they run 24 hours, but they also didn't give us that much information because they were highly flaky. So there would be someone looking at that build and be like, oh yeah, it's red, but it's really fine, and we can really say because it's just a network out, like a network timeout on the test or something like that, right? So what we do instead is we now run L0s and L1s on every single pull request that we submit. And okay, so I'm gonna go to the next one. Okay, so we didn't, this is again, process of continuous improvement. So even Microsoft doesn't have unlimited pools of money. And so we couldn't just go and be like, okay, we have like thousands of thousands of UI tests, and we now want to have thousands of unit tests, and we're just going to stop delivering software and just go rewrite our tests, right? Because the tool would go bankrupt, and get shut down, and nobody would be using it. So instead, we took like 2 years. This is a process of 2 years, and we went from having lots of integration tests to having lots of L0 tests. I'm not going to name it. Okay, so I'm going to go a little bit further. So we do have pull requests on every single thing, and not only does a pull request need to get approved, like so code reviewed by people before it can go into master, but it also needs to run some tests. So I'm going to switch, and I'm going to hope that my internet actually works, so we're going to find out. Okay, so this is actually production system. This is my, this is the Azure DevOps for Azure DevOps. It's like Inception. It's great. And so I'm going to go into one of the builds in here, the one that succeeded, obviously. Right? And so this is the number of tests that we ran as part of this build, right? So this is 84,000 tests that ran into 6 minutes, 47 seconds. That happened like a couple hours ago, right? So this is what we do right now. But it took us 2 years to get there. So if you're not there yet, don't despair. You can get there, and it will be awesome. But what this means, actually, the fact that it's running on pull requests, it means that I cannot merge into master. I cannot make a change that's going into master, that trunk-based development, if it didn't succeed on all the tests, right? And you can assign actually different CI pipelines and do different things and check for different things, right? But you can definitely block things from going into master if they're failing the tests. All right. Okay, so this is great. And last point, so this is our deployment dashboard. This is great. I don't know, something deploys to somewhere. We do have like an on-prem version, and we have an off-prem version, all of these things. The point of this slide, I guess, is that the red means red. So like if your build actually fails, then it means it can't go into production. There's no such thing as like, let's just throw it off the wall, it's gonna be fine, right? And we do every now and again discover flaky tests. So we actually have a nightly process that runs, and that process discovers flaky tests. So it does reruns the process a bunch of times, and if it notices that some tests kind of toggles between green and red, it will like flag that test, and then we will go to look at it and eliminate it. Okay, so I'm not going to talk about this one, but we have all sorts of interesting issues because we are both on-prem and a SaaS service, so it's interesting to support both. But we do much prefer that people use the SaaS tool because it's so much easier for us, not because it makes more money, but because it's much less support hell, because people are still using TFS 2005, and that's really, really, really hard to support. So we don't want to be doing that. Okay, so don't overthink. Learn how to fail fast. This is a great point. Again, the core of DevOps and all these things. So what we did notice is that in this adoption process, what happens is that first when you bring like DevOps transformation into the team, they're like, oh my God, DevOps is amazing, it's making my life so much better and stuff. And then there's this dip because like you face this hard issue that you have to work through. Like the couple examples that I gave was like automating everything, right? Because this could be like weeks and weeks of trying to remediate and dig through all this documentation and figure out how to actually automate it, right? The other one was the unit test, right? Because like we were like, oh my God, how are we going to get to the whole fully automated, unit test that can run like in 6 minutes? That didn't seem right possible. So you do have this like J curve, and like people get happy, and then they get unhappy, and then they get happy again. And then I think that it continues as a wave, right? Because they can get unhappy again about something else, and then remediate that and get better. So basically, a journey of 1,000 miles begins with a single sprint. So like, go fix that thing that hurts the most, and your journey will start there. Okay, so I am under time as usual, so this is good. So my name is Sasha Rosenbaum. You can follow me on Twitter @DivineOps. You can read more about this story at ak.ms DevOps. And this is a rainbow ninja cat because we work for Microsoft and it's awesome.
Well, thank you very much for that. That was highly entertaining, especially the ninja cat. Big fan. Big fan. To the organizer with the timepiece, do we have time for questions? Yes, we do have time for one very good question.
We can have like 3, it's fine.
Oh, 3 is fine. Or 3 mediocre questions, that's good.
But only questions I know the answer to, please. So. Yeah.
Yes, over here in the front.
First of all, thank you so much for talk. And I have a question like, do you create a feature team for each feature, or your feature team just take another feature?
Or feature teams what?
Do you reorganize, do you create your feature team like for each feature, or your feature team just take another feature for developing?
Yeah, so I think this is kind of like a natural evolution, right? Sometimes we do form new teams to work on something, and sometimes like if it's a new skill set that we need, we will form a team that can support that skill set. But a lot of times, like if I'm finished working on something, that feature team will just naturally take on the next thing that makes sense.
So answer is actually it depends of situation.
Yes.
Yeah. Oh, thanks.
Other questions? Oh, right over here.
My question is related also organization within the Microsoft, especially how you manage the knowledge sharing between the so many big teams. So, for example, what the best practices have significant impact to the quality, to the time to deployment, and so on. And second question related to the containers adoption. How much products is already converted to the microservice and running on the Kubernetes?
Okay. Yeah, great. So because I'm going to bring back the ninja cat because it's good. Because Kubernetes is going to solve all your problems. It is an important question. So organizationally, oh my God, what was the question? I'm totally blanking. That's great. Huh? Oh yeah, knowledge sharing. Well, so this is a very difficult question, right, across an organization that is that large, and there's no perfect answers to that. We do send a lot of emails, unfortunately. We also do have SharePoint sites, and we have like GitHub repos that are shared, and we have all sorts of like different ways to share knowledge. But so not all teams at Microsoft are using the same process, right? We do have autonomy, and especially if you go to different products, like, there's this article on the internet that says like, Microsoft doesn't do cherry picking into production, and we totally do cherry picking into production on Azure DevOps team because, we do, because we don't want you to wait for 2 weeks before you get a fix and whatever. So, we do that. We do mandate that people sort of like eat our own dog food because we're not as cool as AWS. We don't drink our own champagne. We eat our own dog food. So, But basically, like we do say that everybody at Microsoft should be, for instance, using our own tools for deployment, because it used to be that like, Office team had their own deployments thing and like that they implemented. And Windows team had their own deployment tool that they implemented and all of these things. Now the Windows team is actually building their Windows images with Azure pipelines, right? And they're like hosting the images in Azure Artifacts. And so like, again, we become our own first testers. So that's kind of a big change. And we do gradually sort of permeate those best practices across the organization. In terms of containers, so like Azure DevOps in particular is moving towards containers. So like when we sort of take and remediate services, we do put them in microservices and in containers, but it's a gradual process. We don't try to break out like the entire thing. You will notice that, so we have like 5 big products within a product, and then like there's lots of different small services within them, and so each one of them potentially becomes a microservice.
Do we have time for another question? Do we have time for another question? No, we don't. All right.
Surprise.
So,
All right.
hey, a big round of applause for, surprise, surprise, the birthday
Thank
girl.
you.
It's her birthday. That's what's up.
Tomorrow. All right.
Thank you very
Thank you,
much,
guys.
everybody. We're going to take another little quick break, and then we'll come back.